Hi everybody, my name is Uriel and I'm one of the main developers of the program LivePyxel. Today I will guide you through the installation process and showcase one of the main attributes that make LivePyxel so powerful in the context of fast annotation using binary mask. So let's get started by first entering the command prompt. I go to my Windows device. I'm using Windows and an environment manager that is called PyEmp, which I need to activate with a respective version of Python. I recommend you to create a virtual environment, which is exactly what I'm going to do here. I start by activating a specific version of my Python interpreter. LivePyxel works with versions of Python 3.10 and above and should not be used with Python versions 2.7 and below. I am not entirely sure on the integrity of the program in versions below 3.10, but I recommend you to install an appropriate version for that end. Once I'm here in the folder where I want to install LivePyxel, I can then create the virtual environment. The process, depending on where you're running it in your computer, should take no more than a couple of minutes. The next step is to activate that environment. If you are working in Linux, you may need to follow a different command. Is source bmb, then bin, and then activate. In Windows, you have a specific bat file that is created along with the version of the interpreter. The next step is to install LivePyxel. Because LivePyxel lives in the PyPy registry, we just need to install it via pip. If everything works well, you should see that the installation takes a couple of seconds, depending on the reliability of your internet access and also the speed of your processors. Once we are here, we can simply type LivePyxel in the terminal with the environment activated, and that is going to prompt us this window, which is the main GUI. Depending on the resolution of your screen, you may experience some skewed GUI elements here and there, but the general structure should look as follows. I already have some objects that I have placed in my scene. These objects are just Nobi bits that I have purchased at the dollar store for this demos video. We're going to be using them throughout. The first thing we do is to go to File and click on New to create a new project. And here I can select the folder where I want my project to be. I'm going to click and select the folder test LivePyxel, which is the one where we started this video. Once this is complete, the program will create a configuration file with the names of the labels at the location where you indicated. These labels have to be saved, and actually if you try to close the program, it will remind you that you need to save those labels. Be careful with leaving the program if you haven't saved those labels, because if you make annotations and you miss those labels, then you may have trouble finding a match in the configuration file. Let's get started. I have these bits that I'm simply gonna place in the camera, and I'm gonna proceed to calibrate the binary mask threshold and also edit the labels here. So this is the bit A, and I have a couple others that are off the screen that include E, Y, and U. I press Ctrl S to save the project, and then I can begin the calibration process. To calibrate, I simply need to go to the 4 icon from right to left in the Tools bar menu, select Binary Mask, notice that the cursor has changed, and simply click in the Canvas section. Here we have two main slide bars. The first one represents the opacity of a mask after an annotation has been completed, so you can see details underneath the image. And the second one is the threshold value that the mask is going to recognize. If I increase the value, more or less of the objects is going to be detected. My purpose, however, is to gather in white, because that's what is producing the mask, all of the components that will belong to that mask. I will put it at around the middle point. And this is where the light composition of your scene really comes into play. You can see that there is some artifacts that start to appear here on the right. I'm gonna fix those in just a minute. But this is the label A. Now the annotation has been completed. Notice that there are some shadows appearing in the annotation that we need to remove. And the best strategy for that is to change the light source to something that is more directly above. This is part of the setup of your environment. That is to be expected whenever you are working in highly controlled environments. Let's turn on the flash so that the light appears directly from above. And let's repeat the annotations. I'm not entirely happy with how this annotation is looking, so I'm just going to erase it. The best way to erase the annotation is to use a boolean, pass the brush and color the image as such. With a new version in place, I can move the bits and apply the mask. And this is something that you only need to do once. Once the mask has been adjusted and the rest of your frames look very similar to each other, then you work under the assumption that those are parameters you don't need to modify anymore. I'm gonna introduce some manual annotations once the annotation has been completed. I'm simply gonna annotate the center in here myself, which is something that I suspect I could have avoided with better illumination, but we work with what we have. Once this annotation has been completed, I simply click on the annotate button. The annotation disappears and I'm ready for the next one. If I click in the first icon from the right to the left in the tools bar menu, I can gain access back to the annotation that I just completed. Let's see how many annotations we can do. Let's try making another annotation. This time I'm gonna try with a different letter. And as before, I simply click in the binary mask tool and press enter. This time, however, the color of the label should not be green, it should be magenta. I click in the magenta color, I turn off the boolean and bring back and select the desired color. I'm gonna add a bit of extra filling here to these annotations. And then I click annotate. Notice that I am annotating everything that belongs to the same category together. This just makes my workflow much faster. The purpose of doing this is that in such control environments, I can simply expand on the dataset by generating synthetic images, which is what the original publication of LivePyxel demonstrates, using not bits but shells. So in that experiment, what we did was taking each of the images with their different masks and using those masks to create transparencies of the original images so that everything but the background is visible for each category for each of the images. And then we started putting them on top of each other. With that, we were able to create a very large data set of over 10,000 data points. As you can see, the process of completing each of the annotations has been dramatically reduced because we don't have to label each of these ones manually using polygon tools. This is even faster than some integrations using the segment anything model, because it allows us to complete every single object in one single go. If you have any questions or you have any comments or encounter any bugs, please let us know. You can access the GitHub repository, and I should take us there. In the GitHub page, you'll find the official documentation along with this and other tutorials in case you feel stuck in the installation process or need additional assistance or code in the next steps that follow the generation of the annotations. In the folder examples, we have two main folders. The first one is an ready-to-go architecture that contains neural network based on UNet that merges also the information from the BGG19, effectively using the weights and biases of BGG19 in combination with the UNet dataset. That significantly reduces the training time because you start already with some of the features learned by the BGG19 network. The second one is an example pipeline with how to engineer your transparencies for synthetic data, which works particularly well with the binary mask annotations that we just completed.